Okay, this is our last section for Module 3. We're talking about probability plots. And these are really nice for assessing if sample data comes from a given distribution. You're not sure. Maybe you wonder, you have a sample data, if it can be modeled by a normal curve or a normal distribution. So there is a really nice way for testing to go in with the assumption that the data probably is from a normal. So that's what we're doing in this section. And otherwise, I mean, if you just had sample data, I think a lot of people do, and you look at a histogram of the data and at least be able to tell the basic shape of the data, and that would give you a good indication what kind of distribution you have. But unfortunately, the way you can bin things different, so maybe the histogram binning doesn't show the normal, or if you have a small amount of data, it might not take on the shape because you don't have enough data to really see what's happening. So this probability plot will be in addition to a histogram, but it'll give us a little bit stronger evidence to suggest which distribution the data comes from. So this just says, suppose you collect sample data and the sample mean is this and the sample standard deviation is this. And remember, these are for samples because the population has parameters of mu for the mean and sigma for the standard deviation. So these are for the sample data. So imagine you collected a sample of data from a population, x1, x2, all the way up to xn, and then you go back to the formulas we used earlier. You could calculate the mean just by adding them, dividing by n, and you could also find the standard deviation. So these are just directly related to the sample. So you think maybe the data came from a normal distribution, but you're not sure. Now, if it really did come from a normal distribution, then the question they're asking here, what would we expect the median to be? Well, if the data really came from a normal distribution, so let's just assume it did, and let's put here as an idea of the true mean, let's put 10, the x bar, and for s, the spread, usually we put sigma, right, but we're just estimating with the standard deviation. But here, the mean, if the mean really is 10, then the median would be very close to 10. Since if you have a bell-shaped curve that's symmetric, about half of the data is below the mean and about half is greater than the mean. So in this case, we would say the mean and the median are about the same. What would we expect the first quartile to be? Well, if I'm treating it like a normal, I would just expect it to be that value that leaves 25% in the left tail, and we could go into Minitab and just say, hey, find this value, which we've been calling Q, find the value Q or P that leaves 25% of data to the left of it. So we're not doing anything new here. We're saying the same thing, but we made a huge assumption that the data came from a normal distribution. So before we do all this, we have to feel pretty good that our assumption is true, or at least it's reasonable. So let's move up here. Well, I'm having a hard time with that. Let's move here. So yeah, so a graphic for assessing if a data set is with a specified, oh yeah, so a graph for assessing if a data set is coming from or can be modeled by. So a graphic for assessing if a data set can be modeled by the underlying distribution is a probability plot. A graphic for assessing if a data set is consistent with or likely to come from, consistent with a specified model for the underlying distribution. So I'm trying to tell, again, the plot is just saying, hey, does this data look like it's from this distribution or not? If the data falls along the theoretical line that's going to be drawn in the probability plot, if I spelled it wrong, sorry, then the data is consistent with the model, and the model is reasonable. So if it does fall along there, I'm not going to say it's exactly that, but it's reasonable to believe it could have come from that distribution. As long as there's no trend or systematic trend away from that line, then I'm going to say, yeah, that's a possibility. The graphic, we can't say for sure that I'm 100% sure, prove that that's the right model. we can only establish that the data is most likely or reasonable to come from that. Only establish if data is, I don't know, consistent or reasonable with that distribution. So the big point here is the graphic that we're going to make, the probability plot, doesn't prove it's from a given distribution, but it makes it seem like it's very likely. So that's what we're going for here, and we're going to use an example we used earlier in this module for device failure. And I think I can explain the plot better and how this line is coming about when I show you what the plot looks like. So here's mini tab, and there's our data from earlier, the weeks. We were trying to see if failure time of weeks is normally distributed now. So I can go to graph first and just do a histogram. And I'll say okay. And a simple histogram, let's just look at the shape. And I have a feeling now, right, here's the graph. I mean, if it was normal, we don't really see that bell shape. I see a long right tail, and I'm thinking, I just don't feel good about saying it follows the normal distribution just from this graphic. So we want to check and be a little bit more definite, and here's where I'm using the probability distribution plot. Sorry, that's a lie. Probability plot, graph, probability plot. And for a single set of data, and the sample data is in the weeks column, and we can try to fit to different distributions. You can choose which one, and I'm going to try to see if it's a normal. The normal, in fact, is the, default distribution. And so let's graph. So let's make this guy larger. So this is what I meant by a normal distribution. I'm taking the y-axis has the shape of a bell-shaped curve. I'm stretching out the y-axis from a 0 to 100, all the probability within a normal, and you can see that I'm squishing the majority of it within, just right around the mean or the center, around 50%, and there's hardly any data right in the tail, so less than 5% or 1%, there's just not a lot there, so I'm stretching out the axis toward the tails. And so basically what I'm doing is I'm making a straight line such that if the data did come from this distribution, then it would lie along the straight line because I stretched this axis to model the normal, where most of the data, again, is in the center. So what we're looking at, and there could be a lot better explanation for that, but basically here's the theoretical line that the data should follow if it does indeed come from a normal distribution. And you can see that it's departing from this line. I mean, it's going outside of these bounds, a confidence interval. So just by looking at this data, it's not following along this line, and I would say that data does not come from a normal distribution. And so going back to the original question, yeah, I don't think, and we kind of had that idea from the histogram, and I'm going to try to fit it to something else just to give you an idea. Let's try you wouldn't know this distribution yet, and don't worry about it at the moment, but I have a sense. Let's just try a Weibull. I mean, if I want to be more certain, we could go to let's even go to a 3-parameter. I'm putting in 3 parameters, so I'm fairly certain that this will fit the data. And so yeah, here you see nicely that now the axis is stretched to meet what a 3-parameter Weibull would look like, and you see the data plotting much closer to this line. So I would have a reasonable. I feel reasonably comfortable saying that this came from a 3-parameter Weibull, but that's for later in the course. And right now, usually we just check to see if the data comes from a normal distribution. So that should do it for us for Module 3, and let's turn this thing off.